Okay, hello everybody, good afternoon. Let me first briefly introduce myself. My name is Mariann and I graduated in 2008 in Budapest at the Eötvös University, of course, as a meteorologist. Right after graduation, I started to work here at the Hungarian Meteorological Service, and I do so except when I am on sick leave, so take a handful of advice from me, be careful when you ride a bike. So I work as an operational severe weather forecaster, but I also took or take part in storm forecasting for our big lakes, such as the Balaton or Velencei Tó, and I also provide hail probability forecasts for the national so-called Jägermeister, which is an acronym for the hail damage suppression system. But unfortunately, we are not provided with samples from the actual Jägermeister company. So after this brief introduction, I would like to know, and probably you as well, which countries are you from? You can use the annotation tools. I hope you can. Now everybody has the annotation tools, hopefully. Okay, so welcome everybody on this weather briefing. And I would like to first present you some satellite data. And this first picture is on microphysics day RGB. And I have some easy after lunch questions, such as you can use or write your answers to the chat box. What are those blue lines or areas in the western, southwestern part of the continent or over the Atlantic? I wait a few seconds so that we can read your answers. Okay, hopefully you will be more active in the second part. So those are shadows because this image was cloud shadows. Yeah, thank you. So this image was taken at 6:55 UTC, which is still kind of early morning in Portugal. And at that time, the sun rays are coming from a very sharp angle. So yeah, those are cloud shadows. Another easy question, could you please mark the areas where there is snow coverage? And of course, you can see, or it can be spotted on this image, under the cloud, snow is not our field of interest right now. Yeah, the Alpine regions. Yep. Over up to the north in Scandinavia too. Yeah, the Carpathian Basin and the sharp-eyed one also noticed in Turkey, some snow-covered mountains. Thank you. On our next image, you can see the Airmass RGB, and it's combined with 500 hectopascal geopotential height and 300 hectopascal wind. You can see cloud systems associated with the lows, and there are some relatively weak and short jet streams which can be found over North Africa, northeast of the British Isles, and a little bit north of the Black Sea in the east. And there are two there's no pronounced zonal and meridional flow, since there are two ridges penetrated from the south, but those are not very well defined either. In the Hungarian media, and during the recent days, the news writers were interested in the Saharan dust and the associated muddy rain. So let me show you an image, the aerosol optical depths at 550 nanometer provided the Copernicus Atmosphere Monitoring Service. And here you can see an elongated band over France, through Germany, up to the Baltic countries. And we do not talk about the other areas. But if you look at the map valid for the day before, you can see the origin of this dust which is absolutely no surprise. Saharan dust is coming from the Sahara. Since the continent is quite covered with clouds during this time of period, I would like to show you an animation. This is a series of dust RGB from the 11th of April, which was this Monday. And unfortunately, even with help, I couldn't get a better resolution, so really sorry for that. But I hope you can still see the pinkish, let's say, cloud elevating from the north part of Africa, where from the border of Morocco and Algeria. And this huge amount of sand or dust slowly starts the journey over the Mediterranean. And at the end of the video, you see that the cloud system gradually covers that pinkish smudge. But this elongated frontal system is the transporter of the African dust, which has now caused a decrease in the optical depths in Western, Northwestern Europe. And I try to show, again, a dust RGB video, because on the following day, on the 12th of April, on Tuesday, there was a dust storm in North Africa, which can be seen on the most southern part of these slots. I think it started in Morocco, but using the borders would have been beneficial, but you know, I'm always learning from my mistakes. So I hope you can see the dust storm moving from the northwest to the southeast, and it has a very sharp edge, but by the end of the video, this sharp, well-pronounced line fade, and the dust will be mixed into the environment. So let's get back to the actual weather situation. This is the frontal analysis from today, 0 UTC, and you can see major systems with occluded fronts from the Atlantic all the way to the eastern parts of Europe. As I already mentioned, there are two ridges penetrating from the south, and the 850 temperature gradient is not present anymore in the lows. So those are really major systems. On the next slide, you can see the rain and sea level pressure. In my opinion, this is not the most active time of the month. There will be more interesting ones, but those major frontal systems are still able to produce some precipitation. The future is going to be a bit more interesting. You can see the 500 geopotential with 850 temperature as well, and it is valid for Saturday 12 UTC. You can see this nice long trough, which is attracting cold air from the north all the way to the center of the continent. And thanks to this cold advection or cold front, in our forecast by Monday, even the snow showers came into the picture in our official forecast. I show you, just to keep the symmetry, the precipitation forecast for Saturday 12 UTC as well. So you can see the frontal system is producing not just showers or rains, but sometimes, or some places, snow showers as well. And finally, I would like to show you an image from our social media platform. The text is in Hungarian, but it says something like that. We have found the reason for eastern cooling, which is not us, but this blue egg. So it was very popular on our social media sites, and in my opinion, it's a good way to attract people. This is a kind of, we say in Hungary, it's a honey thread, which can attract more people to our scientific work. And if you find abstract figures in your forecasting maps, people usually love these, and you can also have some fun. So it's a win-win situation for everybody. So that was the actual weather briefing. Thank you for your attention. and I give the floor to my young colleague Kornel, which is his first weather briefing and probably not the last. Thank you.
Thank you so much, Mariann. Good afternoon and welcome everybody. My name is Kornel and I'm going to show you a little bit unusual, but I think a very interesting case study back on April 5th. Before we start it, I would like to tell you a few words about me. My name is Kornel Komjati. I graduated in July 2021 with a Master of Science in Meteorology at the Eötvös Loránd University in Budapest, Hungary. During my last semester, I've been starting to work at the Hungarian Met Service as a severe weather forecaster. I've been very interested in thunderstorms and tornadoes since I was a kid. Motivated by my interest, I've started to research supercell interactions with surface baroclinic boundaries, and I want to start my PhD in September. Okay, let's start the presentation. As I mentioned, it will be a little bit unusual because I'm going to show you a case study from the USA back on April 5th, 2022. There was a 2-day-long tornado outbreak and we are going to discuss only the second day of this event. Let's see the tornado map. Red triangles show the tornado reports. We have 54 tornadoes, a lot of tornadoes. And we can also see where tornado watches and warnings were issued. I guess the American forecasters did a very good job on the day. Okay, in the beginning, let's check out the synoptic scale pattern. And here is an RGB Airmass satellite product from the NOAA GOES 16 at midday on April 5th. I would like to ask you to try to search cyclones and their frontal zones and so on. Feel free to draw it on the map. Okay, good, very good. Yes. Okay, very good, thank you. Okay, after the Airmass product, here is an 850 hectopascal equivalent potential temperature analysis. Okay, yes, and yes, we have a well-defined cyclone on the Labrador Peninsula and the two center cyclone on the north of the Canadian border and the developing surface low over the southeast US. And now, after the Airmass product, here is an 850 hectopascal equivalent potential temperature analysis from the ECM. We can also see the cyclones at the north side of the map and developing surface low near the Oklahoma-Texas border. There are the frontal zones as well and the very humid and warm air mass directing from the Gulf of Mexico. Let's see the next slide. Another satellite product. It's also from the GOES 16, lower level water vapor and infrared image. It also draws the frontal zones and the synoptic scale patterns, but let's check out the Texas Panhandle, Oklahoma and Kansas region. A cold front goes through that area with very dry air, and it is shown by the dew point temperature map as well. And the dry environment with the frontal wind caused a very suitable environment for wildfire. And here is the next task. Try to find as much wildfire spots as you can. Yes. Okay, great. Thank you. It's a natural color fire product, and now we can see the fire temperature product, and I think we can see much clearer the spots, especially in Kansas, and Oklahoma. Okay. Now here is a video. There is a developing fire in Oklahoma, and we can see the cold front coming. Let's see. So we can see the cold front coming, and boom, the wildfire starts to expand and intensify very quickly. Okay. All right, that was the wildfire section with a little problem, but we are still in the game. So in the second part, we are going to examine the micro and mesoscale environment and thunderstorms features. We can see the 500 hectopascal temperature and geopotential height, and there is a shortwave trough moving into east. So we have a colder advection in the mid levels. Okay, here is the 850 hectopascal equivalent potential temperature field with surface pressure and surface winds barred on 10 meters. We can see a very strong warm and moist air advection in the southeast US from the Gulf of Mexico. And we can also see the developing surface low marked by the red A. So we have a strong warm air and moist air advection in the low levels and the cold air advection in the mid level, which caused a very unstable air mass over Louisiana, Mississippi, Alabama, and so on. Let's see a sounding from Tallahassee, Florida. At 18 UTC, we have a very saturated, unstable profile, but still it's a little early, I think, because the colder advection has not reached that area yet. Let's see the mid-level flow 500 hectopascal. The mid-level jet moves along the south and southeast side of the trough with a different flow, which caused basically a low-level lifting effect. And we also have a strong enough yes, and we also have a strong enough low-level jet in the southeast area, which could help the tornadogenesis as well. And now I would like to show you an interesting pattern that I found when I prepared for this presentation. There is an interesting shape on the surface viewpoint map, and yes, that's a dog. So I think if you see an animal pattern on a map, it might lead to a severe weather threat. Let's see some further examples. Turtle, and walrus, and Groot from the Guardian of the Galaxy Marvel movies. Okay, back on the track. On the southeast and east side of the trough, as I say, a scoreline formed with a linear wave pattern. And can you find this pattern on the radar, the linear wave pattern? It's a little help. The linear wave pattern is basically a waving pattern on radar imagery. Okay, the linear wave pattern is always one of the most dangerous sections of the scoreline with a strong wind shear in the low levels, and there are very high severe weather, wind gust and tornado potential. Here is a satellite image from the GO-16, the sandwich product, composite product, and over the line echo wave pattern you can see a very massive overshooting top. Yes, here is the overshooting top. Okay, and it's a little bit northern section, but still over over Alabama, a cold ring on the infrared image. These features always refer to violent thunderstorms. Okay, here's the photograph from Montgomery, Alabama, before the score line reached the area. There is a well-curved photograph. Strong wind shear in the lowest few kilometers, over 60 knots in 1, 2, and 3 kilometers, which is basically approximately equal to 30 meters per second. It's a very favorable environment for strong tornadoes. And look at the storm motion and the holograph and the holograph shape. The supercell is moving with the bunker's right motion vector into its own precipitation region. So it results in a massive storm mode, a rain-wrapped storm mode. And here is the result, a strong mesocyclone on the Doppler velocity field, and a lot of tornadoes out there. Okay, and at the end, the storm report, we had a lot of tornadoes, a lot of wind damage reports in the southeast US. And as we examined the synoptic and lower scale environment, it was not a big surprise at all, I think. Thank you so much, and happy Easter, everyone.